Okay, so let's do another example. So now in this example, let's consider a traffic light. Let's say a particular city has a traffic light, and at this particular intersection, they have on average one accident every 3 months. Okay, so let's write that down. So this particular, they have one accident per month on average. Okay. Now, so after a bunch of complaints, they decide to make some changes. And so it has been, let's say it's been 8 months. So here's the question. Is that increase in the amount of time it's been since an accident due to the changes? Is it caused because of the changes that were made? Or is it just coincidence? Is it just by random chance? So now to answer that question, we have to ask, well, it's a question of probability, okay? So if we look at, so probability theory says this. If we have time limit, right? So if we're measuring the amount of time that passes before something occurs. And we know that it averages K, right? So if we know that the average is K, right? The average amount of time that something happens is K. And the random variable X, so average time of occurrence of an event, and X is the amount of time that passes. So this is the amount of time that passes since the last event. Now, given this, okay, we know, based on probability theory, okay, that the time between events okay, X. So let's say, given this information, so let's say I want the probability that X falls between 2 times, falls between A and B, okay, is given by an integral from A to B of f of x dx. Now, f of x is a piecewise function, and the reason why we have the piecewise function is because we have to account for all values of x, and the area under the curve must add up to 1, okay, for the whole distribution. So again, without getting into too much detail, let's see what happens here. So the function f of x is equal, oops, do this better. So it's going to be equal to 0 when x is less than 0. So that's how we're defining this. So we're defining function as this. And if it's greater than or equal to 0, then we define the function as k e to the negative kx for x greater than or equal to 0. Okay, now here's the thing. If we're talking about time, x is never going to be negative if we're talking about time, right? Now this is what we call an exponential function, okay? And in fact, this probability that we're talking about is based on an exponential distribution, an exponential probability experiment, okay? So now what happens is we're going to integrate this. Okay, so now how do we determine the probability of this, right? So it's been 8 months, right? So it's been 8 months since the changes were implemented and there has been no accidents. Okay, so let's fill this in a little bit more. Okay, so K is the average amount of time, or excuse me, yeah, the average amount of time that passes between occurrences, or whatever the event is. Okay? Okay, so to answer this question, so just to fill in the details. Oh, 3. There should be 3. No, 1. That part doesn't matter. But is it 3 or 1? I just want to... One every 3 months. So 1 accident every 3 months. That's what it is. Okay. So, if the accident happens 1 every 3 months, then K is 3. So that means we would replace K with 3. But now in this case, what we really want to answer this question is we need to figure out what is the probability of being greater than or equal to 8 months. Because we already went 8 months. So what's the probability that the time is going to go more than 8 months? So let's set this up. So here's our interval. So we want the probability that x is greater than or equal to 8. And based on our probability function, this is going to be equal to the integral from 8 to positive infinity. And since we're greater than 0, since we're dealing with x greater than 0, we're going to use this. Okay? So this is going to be k e to the negative kx dx. And so that is what we're starting with. Okay, now, oh, I'm sorry. Yeah, that's what we're starting with. Okay, now, the k value is what we started with before, right? So here's the other thing to realize. In order to find out to test whether this is based on the changes or it's just by random chance, is we need to operate under the assumption that the average is still 3, right? So what we're doing is we're saying, okay, if there's no, if it was due to random chance, right? Then we want to calculate, hey, what's the probability of getting 8 months or more if the average number of accidents or the average number of time that passes between accidents is still 3 months. Okay? So that means what we're going to do is for K, we're going to assume that K has not changed. We're going to assume that K is still 3. Okay, now, based on this, we're going to calculate this probability using this integral. And we're going to see what that probability turns out to be. If it's really, really small, then that would tell us that the chances of this being by random chance is unlikely. And then it's probably likely due to the changes in what they were doing with the traffic lights. Okay, so now let's change this because we've got this, so let's change this to a limit. So this is going to equal the limit as t approaches infinity of the integral from 8 to t of 3e to the negative 3x dx. Okay, so now let's integrate this. Okay, well the 3 comes out. So what are we going to do? We're going to do this. It's a chain rule, right? So we got e to the negative 3x, and then we're going to divide by the derivative of the inside function. So if we divide by the derivative of the inside function, we're going to divide by negative 3, and then we get negative 1 here. So this is going to equal the limit as t approaches positive infinity of negative e to the negative 3x, and we're going to evaluate this from 8 to t. Okay, so far so good? Okay, so now, let's see what we get with this. Okay, so this gives us the limit as t approaches infinity. So let me get rid of this. What do we get? So this is going to be negative. So let me do this. So we're going to do negative. Now I'm going to do e to the negative 3t minus e to the negative 3 times 8. Okay? And so what do we get? We get the limit as t approaches positive infinity. And what are we going to do? This is, we're going to switch these around because I'm going to distribute the negative sign. So we get e to the negative 3 times 8 minus e to the negative 3t. Okay, now I'm going to rewrite this just to show you, just so you can see what's going to happen. But if you can see, what's going to happen. You might be able to see what's going to happen now just looking at these as t goes off to infinity. But let me rewrite it just so you can see it better. So this is going to be the limit as t approaches infinity. And so I'm going to write this as 1 over e to the 24. Okay? Minus 1 over e to the 3t. And so now it's obvious that this is just a constant, and we're going to subtract off something that's going to 0. So this is going off to 0, so that means, what's happening? Well, this is just going to equal 1 over e to the 24th power, which is, let me see what they give here. What do they give? Oh, yeah, this is going to be, so this is approximately 3.8 times 10 to the negative 11. So again, this is extremely small probability. And so the chances, the likelihood that this result is due to random chance is unlikely. So it's most likely due to the changes in the way they're doing the traffic signal. So other than that, that's about it. See you next time.